Welcome to the third installment of our quantum physics series. If you're just joining us, we highly recommend you check out the first two videos to get caught up on the fascinating world of quantum mechanics. In this video, we'll be exploring the exciting applications of quantum physics from computing to teleportation. So sit tight and get ready to be amazed by the mind-bending possibilities of quantum technology. And if you haven't already, don't forget to hit that subscribe button and turn on notifications so you don't miss any of our future videos. Quantum technology is the study of quantum physics and how it can be applied to solve problems in computing, telecommunications, and more. Quantum computing uses quantum mechanics to process data at an exponential rate compared to traditional computers. Teleportation involves sending matter across space instantaneously without using any conventional means. These two examples alone show just how important quantum technology is today. What is quantum technology? Quantum technology is a branch of physics that deals with the behavior of matter and energy on the atomic and subatomic scale. It's based on the principles of quantum theory, which describes physical phenomena in terms of quantum particles, which are very different from the particles we see in our everyday lives. In this section, we'll explore some basic concepts about quantum mechanics and what it means for computing devices such as computers or smartphones to work like machines that can transmit information across space instantaneously. Quantum computing. In a nutshell, quantum computers are different from traditional computers. They use qubits instead of bits and can handle more complex operations at once. The word quantum refers to their ability to be in superpositions of states simultaneously, like 0 and 1 at once, which makes them much faster at certain tasks than conventional hardware or software could ever hope to be. Quantum computers use entanglement as one way to speed up computation by allowing two qubits that have been entangled together. In other words, they share some sort of connection to perform calculations on each other's states without any need for communication between them first. This is called entangled communication. It's like having two people talking while walking down the street. You don't need both people listening before speaking because they're already sharing intent with each other. And when these entangled particles do communicate with one another, it happens very quickly, which makes quantum computing so powerful compared against regular old hard drives. Quantum teleportation. Quantum teleportation is a process of transferring quantum information. It's possible because of the laws of quantum mechanics. When a particle is in two states at once, it can be in one state and then instantly change into its opposite without disturbing its state. This process is called entanglement or spooky action. At a distance, information can be encoded in the state of a quantum particle, which means that someone else could use this information to send messages from point A to point B, but only if those particles are connected in some way. If your friend sends you an email about something you need to know about tomorrow morning when you're asleep, how will they do this? The answer lies with entanglement between their brain waves and yours. And if there are enough shared connections between each person's neurons, neurotransmitters, then we could talk telepathically without even knowing each other's names. Some of the most important uses of quantum technology. You may be aware of the above, but here's a quick rundown. Quantum technology is used for encryption and communication to create secure keys for your computer. It also allows you to send messages across long distances without being intercepted by hackers or eavesdroppers. Another important application of quantum technology includes teleportation, the ability to transport one object from one place to another instantaneously. This can be done simply by separating two objects in such a way that they become separated but retain their properties, e.g. mass, while still remaining connected by quantum entanglement, then sending one object over great distances without destroying it or losing any information along the way. The future of quantum technology. Quantum computers will be able to solve problems that are impossible for normal computers. They're still in their infancy, but researchers are already seeing promising results from the use of quantum principles. In the coming years, these devices could revolutionize many areas of science, from medicine and cybersecurity to energy generation and transportation systems, such as self-driving cars. Quantum technology has many great uses, but it's still in its early stages. It's important to note that quantum technology is still in its early stages, and many people are working on it. The field has been around for less than 100 years, so you might think that there would be a lot more research done on this topic. However, there are only a few companies who have managed to get their hands on quantum computing systems and use them commercially. This means that it will take some time before we see any widespread applications for quantum technology in our everyday lives, if ever. Furthermore, since many different fields of science, such as chemistry, rely heavily on mathematics and physics, it may take another 50 years or more before we start seeing major changes from this field as well, and even then, only within those fields themselves. Quantum technology has the potential to be a powerful tool for both computing and teleportation. It's still early days for quantum technology, but we can look forward to seeing many more applications in the future. Thank you for watching Quantum Physics for 3, from computing to teleportation, exploring quantum technology. I hope you enjoyed learning about the exciting applications of quantum physics. If you found this video informative, please consider subscribing to our channel, giving this video a thumbs up and sharing it with your friends. We'd also love to hear your thoughts and questions about quantum technology in the comments